Hi, welcome to Ash Grove Cement Company, Durkee, Oregon. I am Terry Kirby, the plant manager of this facility. This is one of 8 facilities owned by Ash Grove Cement across the United States. Ash Grove is an American-owned company headquartered in Overland Park, Kansas. Our employees are very proud to be a part of an American-owned company, as evidenced by the flag on the preheat tower. The Ash Grove Cement Company has a strong and long-standing tradition of service, reliability, and quality that reaches back more than 134 years. A pioneer of the lime and cement industries, the company was incorporated in Missouri in 1882 as Ash Grove White Lime Association. The 8 cement plants operating in Ash Grove system are some of the most efficient and best maintained in the country, and have an annual production capacity of nearly 9 million tons of cement. Ash Grove is the 6th largest cement manufacturer in the United States. The quality Portland and masonry cements produced at these plants are used in the construction of highways, bridges, commercial and industrial complexes, single and multi-family homes, and a myriad of other structures fundamental to America's economic vitality and quality of life. We will now take a tour of the facility.
Hi, my name's Rick Wallace. I'm the quarry superintendent here at the Ash Grove Durkee facility. The primary purpose of the quarry mining facility here at Durkee is to provide the 3 major raw materials in the Portland cement manufacturing process, that being calcium, silica, and alumina. We get our calcium supply from our limestone pit that is located to the left of me. Our silica comes from our shale supply, and our alumina source is derived from 2 separate clay pits here on the property. We currently operate 2 blast hole drills to prepare the limestone for blasting. We drill a 6 3/4 diameter hole, approximately 45 to 49 feet in depth. We actually try to bench with a 45-foot back wall. The back wall, the reason we bench the limestone quarry is for ground stability, to make the pit safe, to prevent the mountain from sliding. We usually try to drill 70 to 100 holes per shot. We fill each hole with approximately 400 to 450 pounds of ANFO, which is ammonium nitrate and fuel oil. The ammonium nitrate and fuel oil is basically, it's mixed in the ANFO truck as it's augered into the holes. We double prime each hole for safety with 1-pound boosters, and then everything's wired in with delays. What we try to do is when we shoot, we try to cast as much material into the pit as possible with the powder versus pushing it with the dozers. Once the rock is shot, we bring the dozers in, and then we'll push the remaining shot rock off into the main pit or into a loading zone where it can be loaded with the loaders into the haul trucks. Haul trucks are 100-ton net weight trucks that haul directly and dump into the primary crusher, where the rock is crushed into a 10-inch minus material. Once the rock's crushed, it's carried out through a conveyor belt and stacker into a stockpile where there's tunnels with vibrating feeders underneath the stockpiles, and the rock is extracted out of the stockpile and sent down another set of conveyors down into the secondary crushing system. Okay, we're now at the secondary crushing system. The rock, the 10-inch minus material produced at the primary is drawn down to the secondary, and where it passes across the double-deck screen, and we screen off the sized limestone, the 2 to 5-inch material that is distributed out in the stockpile here behind me. That's kind of the white color, what we call a sugar rock. Again, it's just a high-grade size material. The fine material, 2-inch minus, is then taken out to the cement rock pile just on the other side of the sugar rock pile, and that material will go to the plant. to be used in the cement making process. Anything over 5 inch that doesn't pass through the screens is returned to the secondary cone crusher, where it's recrushed and then redistributed to the screen to be screened again. We produce about 300,000 ton of sugar rock that goes out to the sugar factories in Idaho, and usually about 1.5 million tons of cement rock to be used at the plant.
My name's Phil Teinze. I'm the production manager here at Durkee. My team's responsibility is turning the raw materials from the quarry into clinker and then into cement. So what I'm going to do is take you through the steps that we do in order to make that process happen. For starters, the raw materials from the quarry we store in these silos behind me. We store our limestone, our shale, our clay, and then some iron ore that we buy from outside. Those materials have the main oxides that we need to make clinker and then cement. Underneath these silos we have weigh feeders. So what those are a belt with a scale underneath that tells us how much we're feeding out of each silo, so we can precisely meter in exactly how much of each material we want. Those materials then in aggregate all together pass through our gamma neutron analyzer. So that's a chemistry control device that'll tell us precisely the chemistry of the material that's going through there. It takes a measurement every 6 minutes, and then that feeds into our quality control computer, and that tells us, how close to quality target are we? Do we have the right percentages of limestone and silica and alumina that we need to make cement? Then from there, the raw materials get fed into our raw mill. Inside that building is a large vertical roller mill. What that is a table with some large tires that are about 6 feet tall. That the table rotates. It's driven by a 1700 horsepower motor. And the tires, the pressure between the tires and the table is what grinds up the material. A fan provides air that lifts the material up through a separator. The separator is a cage with fins on it that spins, and that controls the size of the material. So the large material, the material that's too large falls back to the table and gets ground again. Material that's fine enough to meet our specs, that passes on through, and then we collect that later on in the system and we store it as kiln feed. And I'll walk you through that when we get to that part of the plant. From the raw mill, the talcum powder fineness material gets captured in those 2 cyclones, and from there we use an air slide, it works a lot like an air hockey table. So flow the material downhill, and it flows like water down to this bucket elevator, which feeds the raw material silos, the kiln feed silos. These silos store about 10,000 tons of powdered kiln feed. The next step in the process is preheating and then calcining the dust to get it ready to turn into clinker in the kiln. We use a couple blowers with weigh feeders to blow the material, that kiln feed dust, up to the top of the tower, the preheat tower. The purpose of the preheat tower is to be a heat exchange and slowly heat up the material and begin to calcine it. Calcination is the process of driving off CO2 out of the calcium carbonate. So you end up with just lime. So calcium carbonate, CaCO3, you remove the CO2 and you end up with CaO, or lime. That happens in a series of stages in these cyclones behind me. The material before it hits the kiln is about 90 to 95% calcined, which means almost all of the CO2 has been driven off at that point. But it begins to get very sticky at those temperatures because we're talking about 1500 degrees or so. So at that point we need to transfer it to a rotary kiln so we can keep the material rotating and flowing.
The kiln is the heart of the cement plant, and its purpose is to finish the calcination process that we started in the tower and form the intermediate product that we call clinker. The kiln is 216 feet long, 14 feet in diameter, and it spins about 3 to 4 rotations per minute. Our kiln can make 3,300 tons per day of clinker. Clinker is the intermediate product before we make cement. The kiln is made out of 1-inch thick rolled steel, although in places it can be up to 3 inches thick underneath the tires, which are the main supports for the kiln. And on the inside of that steel, it's lined with a 9-inch thick refractory brick. This kiln is driven with a large gear attached to pinions and motors. So what happens on the inside of the kiln is the hot material coming out of the tower goes into the kiln, and as it heats up it goes molten, and it chemically recombines to form a new ceramic material. That's the clinker. This happens in the burning zone, and that burning zone can get up to about 200 degrees Fahrenheit.
All right, the burner pipe shown here is how we introduce fuels into the kiln. So we'll burn either natural gas or coal through this burner, and that's how we heat up the kiln and turn the raw materials into clinker. From the kiln, the glowing hot clinker, which became molten in the kiln and rolled into a ball about 1 inch in size, about the size of a grape, that material falls down into the cooler. The purpose of the clinker cooler is to quench that clinker as quickly as possible, and also to recover the heat that comes off of that material, so that we blow a lot of air through the clinker cooler and cool that material off. The air gets reused in the process to increase our efficiency, and then the cooled clinker is stored in the clinker silos. The 6 silos shown here can store about 33,000 tons of clinker.
On the inside of our 4,000 horsepower mill, we have steel liners with a wave shape that can be several inches thick. The wave shape causes the steel media to tumble and roll inside the mill, and it's separated into 2 compartments. The first compartment has balls that are about 3 inches in diameter, and those balls, as they tumble, they crush up the clinker and the gypsum as they come in through the mill. The second compartment, which is larger, has a bunch of 1-inch balls, and those balls grind up the material into the fine powder that we call cement.
And that material then passes into a separator, which we use to control the fineness of that material, which gets even finer than the kiln feed we looked at earlier. From the 2 finish mills, the 2 cement mills, we pneumatically convey the cement to cement storage. So now we have a finished product, it's ready for sale, and we store it in our cement dome and in our 4 cement silos. The dome can store about 45,000 tons of cement, and the silos can store about 8,800 tons each. And believe it or not, that's not enough to make it through a summer month. We sell about 100,000 tons a month during the summer, and that all in sum is about 75,000 tons. This cement plant is capable of producing about 1 million tons of cement a year, which we ship all over the place. Our shipping split about 60% rail, 40% truck, and our electrical and thermal efficiency at this plant is the best in the company, and that great performance really allows us to ship our cement a long distance. Behind me is our loadout. So we take the material from the silos and we put it into 2 loadout bins, and then from there we just gravity feed the cement out of the loadout bins into either trucks or into rail cars. At this point the material is very fine, and so it'll flow just like water if we add a little bit of air, and it'll just slide right out of the bin and into whatever storage container we want. Like I was talking about a little earlier, our efficiencies allow us to transport material very far. Our product is shipped out by rail and truck to local and faraway markets. Our markets extend from Portland on the west to Jackson Hole, Wyoming on the east. We ship as far north as Edmonton, Canada, and as far south as Elko, Nevada. At one point, we even shipped down to Las Vegas. Due to the remote locations in the west, our product must be shipped an average of over 200 miles to reach its final destination.
Our mercury reduction system was installed voluntarily in 2010, and it reduces the output of mercuric gases by 98% from our plant. The system meets the federal standards for mercury control. The way the system works is after the kiln, the gases from the kiln go through the main baghouse and then through the mercury baghouse, which has powder activated carbon in it, which then collects the mercury. From there, the gases go up the stack, minus the mercury. We have installed an SNCR system to reduce output of nitrogen oxide emissions. What you see behind us is one of the skids of two that we have on site. This one feeds into this tower to reduce our NOx emissions. The system introduces aqueous ammonia into the preheat tower at the correct location to react with the nitrogen oxides and reduce them to stable nitrogen and water. This system went into operation in March of 2015. Clean air, water, and responsible manufacture are important to us and our neighbors. Our plant monitors emissions to ensure that we are doing all we can to take care of our planet, pass it on to our children. Our continuous monitoring system behind here monitors for PM, CO, CO2, nitrogen, mercury, and VOCs. These analyzers have gases pulled in from the stack on the other side of this room. In addition, we also monitor for metals and sulfur through stack testing. We monitor discharges of stormwater from our facility and work to ensure that erosion and solids transport are minimal during rain events. We actively work to properly catalog and dispose of all types of waste and ensure that nothing comes on site that we do not have documentation. Ash Grove has spent well over $20 million in capital environmental controls at Durkee alone over the past decade. We feel that this demonstrates clearly our commitment to operating our plant in an environmentally responsible manner.
Hello, my name is Paul Peterson. I am the maintenance manager. We're responsible for maintaining the facility, both mobile equipment and stationary equipment. We perform these services using techniques such as vibration analysis, thermography, and oil sampling. Reliability is a major focus of Ash Grove company and of the plant. We focus on reliability to keep the plant operating at high efficiency and throughput, which minimizes downtime for the operation and maximizes operational efficiency. Our repairmen are capable of performing many types of repairs that involve welding, fabrication, machining, electrical maintenance, and construction. Skills for the trades are maintained through an electrical apprentice program, vendor-supplied online training, and numerous on-site and off-site training programs. Our department is also responsible for maintenance of storehouse of repair materials needed since we're so remotely located. Over $6 million of parts inventory is maintained here. We also have planners and purchasers which provide the detailed planning and requisition capacities to ensure our maintenance department has needed resources to keep the plant running, with a focus on planning so our repairmen can operate in the most efficient way possible.
Hello, my name is Rick Bulow and I'm the safety manager at the Durkee Cement Plant. By now you've seen the travel log of the quarry and the plant, all the operations, and I will admit that there are ways that you can get hurt here. That's why safety is such an important value at Ash Grove. Every single person who comes here every day works safely, and to be honest, if we can't do it safely, the work won't be done. This is a core value of ours, and as a testament to that, we have gone about 1,650 days without a lost time accident, which is 4 years, and that is indeed a record. How do we do it? We build a culture here so every single person takes individual responsibility to be safe every day. Everything they do, whether it's sweeping or shoveling or installing a piece of equipment, we try to find the very safest way to do it, and we have very high expectations. So that's one of the proudest accomplishments of the Durkee plant is our accident record and that the safety culture that we're building. We've got stretching programs. We have every single job has a job safety analysis built in. We've got a very vibrant safety committee, and I'm very proud to work here, and I think that all of us are proud of the safety accomplishments at the Durkee plant.
I hope you've enjoyed the time you spent learning about our plant, people, and culture. I think you will agree we have an organization that thrives on improvement and wants to succeed. Our employees make the difference. The 78 hourly employees and 33 management personnel welcome you to our plant and look forward to answering your questions. Thank you.